terms that you already know, but we're going to introduce them with different ways of writing them and how you label. I said this before, geometry is a hugely visual math topic, so the quicker we get, or the better we get at labeling and drawing pictures and stuff, it gets to be so much easier. Also, geometry book definitions suck, and we try to make them as easy as possible to make sense. And a lot of times a long-winded book definition is the worst thing in the world, but yet you can just draw a picture of it and be good with it, and you would know what it means. So we try to do a lot of that as well, because you're not going to read a textbook and have to go through the paragraph thing to figure out what something means, when you can draw a picture of it and know exactly what you're talking about. I'd rather do stuff like that, make it easier on all of us. So let's just do some easy stuff today. What's a point?
Wait, is this vocab?
Yeah, the geometry has a bit of vocab. We've got maybe 6 or 7 things today, and I'd say you know all of them except for maybe 2. Nope. Absolutely, man. I'm just messing with you. You don't have to ask about that. I appreciate it. I'm a jerk, so it's all right. No, that one doesn't work. Use the one in the back. Did we have that problem? No. I thought we did. Oh, never mind. So yeah, this pencil sharpener is awful, hence why I covered it. There's a mechanical on the back is much nicer. Think about, what is a point? What would you think a point is? What do you got? A spot, a dot, okay. A solid spot. I've never heard the word solid in there before. What else? Think of something else. What do you got? A specific place. All right. Coordinate, okay. Now, a coordinate is even more specific than that, because it's telling you left, right, up, down, whereas a point is really just a generic place in space. And I don't mean space like in outer space. I mean, it's just some spot, some place, something, somewhere. It could be anything. A solid dot, a solid, I don't want to say space, but a solid position. It's really, you are here. That's all it is. And in geometry, we label them. A lot of times in geometry, we label stuff, well, more often than not, capital letters. Point A. Pretty simple. And again, I know you've all seen it. Somewhere along the line, you had some geometry section in a 6th grade math class or a 7th grade math class that you had to do that. Okay. What's a line?
So what?
What's a line?
A line? Well, there's different types. Like if you put a point at the end of a line, that's where the line stops.
Then it doesn't no longer ceases to be a line. What does it become?
Array.
Yeah.
Array. Very good. But what would you define a line as? Yes, sir. The thing connecting 2 points together. Okay, but that could also be a segment, couldn't it?
Yeah.
What do you got? What do we call that? Remember what that's called?
A line doesn't end.
Well, what do we call it when it goes on for? It's infinite. Yeah, a line is an infinite. Remember that? You ever seen that before?
Yeah.
What does that look like?
Sideways.
It's a sideways 8. What else does it look like?
Infinity. Xfinity.
Yeah, I could be racetrack.
It's a Pringle.
That's
Oh,
not
it is! From,
It's a Pringle.
that's neat.
It's a Pringle. Do you know the reason why Pringles are shaped that way?
So many
Think-
of them.
No, this is a true thing here.
That doesn't look like a Pringle.
Oh, I see it.
Yeah, it does.
All right.
Think about
But
it.
yes, sir. They stack easier, but the reason why a Pringle is shaped that way is because there was a mathematician who liked potato chips, and he was sick and tired of half of his chips being broken. All right, think about it. Your bag of chips, you can start out, you got a pretty good amount. Then after a while, they still break, but in nature, what's the strongest shape in nature?
So,
A curve. An arch. Arch.
yeah, me too. I thought it was a triangle.
Yeah, the
Well,
triangle
alright.
is stable for building, not
Same with
in
building,
nature.
but like an archways can hold structure.
Yes.
All right. So the Pringle. Now this is a great word for Scrabble. Is a hyperbolic paraboloid.
A big word.
Exactly. Hyperbolic paraboloid. A hyperbolic paraboloid is what we call a conic section. You guys have all done with parabolas, right? Up like a cup, down like a frown.
Yeah.
You hated factoring.
Oh.
Pretty simple stuff. Yes. Now, conics are curves. You know, you've got your parabola, you've got an ellipse, a circle is a conic, and you have what's called the hyperbola. I always forget what they're called. But those are all what we call conic sections. The Pringle is a hyperbolic paraboloid. And the reason why the guy made it is because he didn't like broken chips, so he created that. Now your life is fulfilled. Knowledge. You guys are so smart now. Anyway, it's an infinite series of points.
Infinite series.
An infinite series of points that extend in two directions. You guys all know that. It's not a big deal. When you draw a line, what does it have? 2 arrows here. A line has 2 arrows. The reason that it has 2 arrows is because it shows that it's continuing in both directions. And you all knew that. The only thing that was new out of that was the whole throwing in the hyperbolic paraboloid out of the infinity symbol. Okay. When you labeled this, you would say that this is line BC with the arrows over it. If you don't put the arrows over it, what does it become? A line segment. Very good. It has endpoints then. If it has 1 arrow, what is it? Array. Okay. What's another way I can say this besides BC? CV. Does direction matter when you're talking about line? Does direction matter with a segment?
Yes.
Yeah.
No, it doesn't.
Wait, yeah, no, it doesn't.
From here to there is the same distance from there to here. But what about a ray?
Yeah.
Ray matters because it has an endpoint and just infinite the other direction. So when you're labeling these things, you can call it line BC, you can call it line CD, and sometimes they use cursive lowercase letters, line L, you've seen that, N, whatever. That, again, nothing new. The only thing I'm trying to throw in there is that the directionality portion of it doesn't matter, but you kind of knew that without really having to know that. If that makes sense. That doesn't make any sense. No. I don't know what I'm saying half the time. I make stuff up a lot.
There's words in it.
It's words. I've had lunch and I'm full and my head is tired.
I'm sorry.
And then we have planes.
Plane.
Yes,
Here,
my God.
the
word error. There you go.
And that's a joke. Do you know these things bounce?
Oh, that's pretty neat.
Yo.
I like this.
Do you want to bounce it?
No, okay.
Easy, you're
Well,
playing game. That's it.
I think you guys were like,
You
something wrong. You just want me to bounce it?
Bounce a plane. It's fun.
I'm gonna bounce.
I know.
The sky, look.
No.
It's up there.
Just-
The sky.
Do you guys now think about this back to into a geometry thing. You know what a plane is, right? What's a plane in terms? Think about it in terms of geometry. I know we've only been geometry for like half an hour. What is it? A space. Okay, narrow it down. Correct. That's all it is.
What?
A plane is a flat surface that extends infinitely. Excuse me. Yeah, it's. I use symbols a lot of times, but I forget how to spell stuff. So, infinitely, I'm sure there's an E and a finite, and,
No.
but that's much better. Now, in geometry, there are other types of planes but in high school, we only deal with it, the flat surface. You guys know what a sphere is, right?
Yeah.
A sphere is its own plane. It's its own space. And there's all this other stuff you can do about spheres. And when we talk a little bit about that later on, I'll show you something cool with it. There's also one called a gap plane. It's weird. There's a Minkowski plane. There's a whole slew of other really, really crazy math things that you will, unless you go to like one of the STEM fields, you probably will never have to see when you're in until you're in college. So for our purposes of a plane, a lot of times we draw planes like parallelograms. And a plane, you need 3 points that are not on the same line. Yep. 3 points not on the same line creates a plane. Because if they were on the same line, it would just be a line. And you don't know what direction that line is going until it gets placed into a plane, and then you know what direction the plane is on. Does that make sense? Because I can have a line in space, and it can be going anywhere, but until I get that secondary point on there, I won't know which direction this is going with it. This is nice paper. All right. Planes, you just say that it's plane. Was this D, E, F? Oops. Plane D, E, F. Sometimes it'll say, instead of the word plane, it'll just draw a small, what is that called? Parallelogram there. Sometimes it'll just say a capital letter, and usually that capital letter is cursive. There's just a bunch of different ways of doing it. So when they're in the plane, excuse me, when they're in the same plane, that just means they're not on they won't be on the same line. I mean, you could be on the same line, but you need 3 points to create a plane. You need 2 points to make a line. See? What else are we going to say about planes? Do you guys agree that, right? I just thought something. The front wall can be considered a plane? You think the ceiling could be a plane? What happens where the two planes intersect when they run into each other? What do you know? Well, look over your head. What happens there when the back wall and the ceiling hit? There's a what? A line, exactly.
So it's no, right?
It's no. Yeah, and that's the thing. A lot of times in geometry, you're looking for what happens when things run into each other, when things intersect. So let's talk about what's called intersect. Oh, let's do this first. Collinear, non-collinear. Forgot this was next. Got ahead of myself. Types of points. This is going to be kind of the new one. I don't think you've heard this before, but you know what it is. It's super easy as soon as we start talking about it. Collinear. What does linear mean? Line. Collinear just means shares the same line. Points on the same line. Very, very, very easy. Non-collinear would be then SMRT.
You know the principle.
Yeah.
Yeah.
Oh, you're thinking function,
Mm-hmm.
the vertical line test?
Yeah.
Collinear? Smart, right? On same line. Or I should say points. This would be points, not. The reason why I wanted to make sure you guys saw this was because a lot of definitions later on go back to the idea of collinear, non-collinear. So if we understand that collinear just means there are points on the same line, non-collinear, points not on the same line, when you read those terms later into more complex things, it'll make a little bit more sense. Yes, ma'am? We did embarrass you. Are you having a good day, though? Good. Not too bad? Oh, here we go. Which is which? Segments, rays, and lines. Which is which? We talked about it. You already know what all these are. What's the top one?
A line.
What's the second one? And the last one is?
Segment.
Now remember, when you're talking about lines, let's see, we left off at G, right? So this is H, I, J, K, L, M. If you're going to label these, remember you can label them a couple of different ways, especially for lines. Lines, you can label it as line HI or line IH. Doesn't matter, just two different directions. It's still the same line. When you label array, no matter what, the endpoint letter always goes first. The endpoint letter always goes first on arrays. So even if your array is pointing, in this case, let's say our array is going to the left, and let's say this was XY, it would still be array XY like that. Does that make sense? Wherever the endpoint is, always goes first. It's really the only rule in that. And then the last one, obviously, is segment.
Just casual.
Okay. All of that you knew. You might not have known the array thing about the labeling, but I think for the most part, you guys all knew that. I hope, right?
Yeah.
Yeah, bueno, es muy importante. Opposite rays. This is another important term that comes up from time to time. We talk about opposite rays. Opposite rays are just rays that have the same endpoint. And they create a line. That's it.
Wait, so opposite rays is the line.
Yes, sir. Opposite rays are two rays that create a line. We make it as easy as possible for the definition here. Opposite rays just means they have a common endpoint, and that common endpoint going the other two directions creates the line. If they don't create a line, what do they create? They create angles. Rays that are not opposite would look like this. They create an angle. That's a whole other thing we'll talk about on Thursday. Okay? And you all knew that. Remember what this spot is called when two? Very good. Better than me before I even say the words. Okay. So opposite rays, we use that terminology a lot when it comes down to talk about what are called linear pairs and supplementary angles and things like that. You'll see that opposite ray thrown in there. I think that might be new. So opposite rays are just two rays that create a line. Pretty straightforward. Excuse me. Intersection. Don't write this down. This is awful. This definition's.
Intersection.
When things intersect, what do? They come together. If they come together, that means they do what? They meet. Intersection is just where things meet. Like what? Correct. Two cars can meet in an intersection. It's usually not good. But intersection is nothing more where things meet. And you've done this before. It's where things meet. Remember last year in algebra, you did stuff like this where you had 2x plus y equals 8, y minus x is 4. And you were solving what we call a system of equations. What you were doing there is you were looking for where two lines intersect. Two lines that intersect, if you have two lines that intersect each other, they meet where? At a point of intersection. That point of intersection, you guys would find that out to be some value of x and y. You found the intersection of lines before. They might not intersect. They could have been parallel. Now, we do the same thing in geometry. We talk about the intersection, but we talk about it in terms of, well, we know that two lines intersect at a point. We know that, remember how we talked about this a second ago, the plane on the front wall, the plane on the ceiling, and it created a line. Planes can intersect to create lines. Now, what I want you to try and do is draw the intersection of a ray and a plane at one point. Draw me the intersection of what you think a ray and a plane would look like at one point. And this is where you have to be a little uncomfortable with try it. What's that? Draw it. It sounds, it's, I don't know what it is. I want you to try it. And I'll draw what I think it is.
Hey, what you mean you don't know what it is? You do know what it is.
I might not.
I forgot what it
A plane?
Yeah.
A plane is I don't know, a flat surface that extends infinitely.
Just a green. Not on the point.
Just a casual.
Where's your plane? That looks a good second. What is it? How did I draw? How did I say that planes were?
I think I just did it. I think
Oh,
I
your thing is on your plane. When I say planes were used drawing fast. Parallel. Draw parallel. See what I'm saying now? So think of it as in terms of a plane, what it would look like.
You're probably not right, but you can look at it.
Irritated.
Where's your plane?
What do you mean?
What does a plane look like?
You said it was, look, see, I got an example right here.
Yeah.
You said that, right? So you baby, so I could write a triangle, and that's a plane.
No, but the plane is usually defined with that. And that's the thing. A lot of this stuff, you never thought that you had to do some sort of a visualization of it, and it makes it much easier. Get out of my class right here. I usually see that one a lot. I see
What'd
that
you
one a lot.
think?
I don't even know. Is it a possible line? That's what I think. It's not going to be right. It's like a planet. Where?
Okay, let me just casually. Bro, I think I got it.
Looks like a mixtape.
Right here, sir.
What do you got, bud?
I'm not sure if it's gonna be right. It's probably not. But come look at this, John.
That's all right. Now here's the thing, though. This is where things get kind of weird because you're drawing something that actually is occurring in a three-dimensional world on a two-dimensional surface. So it's tough to actually visualize what it is, but you're on the right track. I know exactly what you're doing. And guys, it's a lot of times with this stuff, it is really weird because you're not used to having to do something like this. And that's where people have problems sometimes with geometry going, it's okay that you can try and be wrong, but here's my representation of snakes on a plane.
Oh, come on, bro. Oh my God. It's a joke to you, bro.
But a lot of what was that?
Did it bounce too?
Oh, I don't know. Let's see.
Because that's a snake on it. Does the snake bounce? Snake doesn't bounce.
Wait, let's see if we can bounce at the same time.
DHS. Yeah.
Ready? Bing. I don't want to be on that plane.
You probably.
Or that one either.
Well, you're in a room with snakes in it.
Actually, you know what? You know why you ever seen the vomit comet?
No.
Yes.
All right, the vomit comment is where you do zero, where they do 0G. You go up, they go up like this, and then they just go. Whee! They nose dive, and you have weightlessness then. And then they have to pull up, and do that again. And then they go. Whee! A lot of throwing. That's why they call it the vomit comment, because a lot of times you're throwing up all over the place. Now that we've all had lunch, good conversation. So here's what I would say.
So that's what it was.
That's all it was. That's all it is.
Gee, that's what I wrote down, but I wrote
It's
another.
okay.
Wait, but I have a question.
Yes, sir.
Like, what if you write another point on the line? Well, on the right.
Oh, that's fine. Yeah, that's fine. You did this?
Yeah.
Yeah, that's fine.
All right.
That's perfectly fine. Now, it's just, and that's the thing, guys. A lot of these terms, stuff that we start with, it's just that you're not accustomed to having to draw something mathematically. And this first section is like that. And this first section is going to annoy you because of that. Because you're like, and you will overthink it more than you really need to. It shouldn't be as complicated for what you're thinking. Okay? It should never be that complicated. I only think I have a few words left. Don't write this down, but I wanted to talk about what these mean. The new textbook brings up these two terms pretty regularly, postulate and axiom. Postulates and axioms are basically terms and definitions that you don't need to prove. They aren't like law of gravity. That it happens. A lot of times with postulates and axioms, you use them, but you don't have to prove that they work, if that makes sense. It's more for proof-based geometry for later on, which we won't get too crazy with. But if you see postulate, or they'll say it's the line postulate, let's say 2 points determine a line. That's what a line postulate is. Or an axiom is just like another way to say, instead of saying definition of a right angle, they'll use an axiom instead of definition. Means the same stuff, okay? So if you see those terms, just think of it in terms, it just means like definitions, okay? Does that make sense? No?
Wait, so basically when they say that, postulate.
And I'm gonna show you how they word it in this book. They use postulate 1.1. I would never tell you to remember.
What is postulate 1.1?
Who cares? All I need you to know is 2 points make a line. All right, that's it. No one's ever going to ask you to regurgitate postulate numbers, unless you're in Geometry 353 at Northern. Our teacher made us do that. We had to memorize hundreds of postulates and axioms. It was stupid. Because another textbook would have had labeled it a different number. So, I'm not bitter.
Not at all.
Not at all.
No. People always ask, how do you draw two planes intersecting?
With a dot.
With like this. Someone last hour thought of it. You know how they have the windows that you can just slide out? How they rotate out? He's like, oh, that looks like a window that just rotates out. Like, huh, I never thought of that. What's that? So, I don't know. Some people think of it that way. You guys will find out rather quickly, I am a horrible person. I mean, artist. I can't draw anything to save my life at all. So I use buttons and things, and Smartboard's great. That's all I had. I think that's all I had. Oops. I didn't do that. Now, what I want to show you real quick, if you have your Chromebooks or whatnot out, this should be like 10 minutes. And if it takes you more than 10 minutes, stop, because it shouldn't take more than 10 minutes. Now, I'm not collecting it. I will do the homework checks after a quiz, but I'm expecting that it'll be done. So I'll go over it if you got questions and all that. I'm not worried about that. But yeah, what I want to show you guys again, what I would do if I were you, when it comes time, towards the end of the hour, we start saying, hey, this is what we're going to do for homework and whatnot, if it's out of the book, I would get my Chromebook out, I would either screenshot it, or I would just take a picture of it with my phone. Or I'd take a picture of this with my phone. Because you're not going to lose the piece, you're not going to lose your phone, you'll probably lose the piece of paper at some point in time, but take a picture of it. That's why I put it up there. You know, take your Chromebook out, go to the website. I will show you also, if you remember on the calendar, I have it on the whiteboard here too, in case you didn't see it. I'm going to show you how to get to it again. Yeah, I will. And if you want to take a picture, that's fine. Excuse me. Remember, guys, you're in geometry, in case you forgot. It's Monday. Click on it. And right there in the description, it tells you what problems and everything to do as well. Unfortunately, I don't have PDF files of this textbook, so I can't load the PDF files for you guys just to download them right then and there, because that would be illegal. I'll probably have it by next year. I didn't say that out loud, I was joking. But remember, to get to the textbook, you have that in your apps tab, I believe, on your Chromebook. Or you can just get to it from the website. Let's count. 3, 4, 5, 6.
Realize.
7, 8, 9, 10, 11. I think we're only at 11 clicks.
No, well, don't you have
11 clicks to get to the textbook. I'm not bitter about any of that. For you guys, it's not as bad. If you want, ladies and gentlemen, if you would like, come on up, take a picture of it with your phone.
Is this it?
Yeah, it's it right here.
That's the whole homework?
There's a second page to it, but if you want to take the front page and then give me a second, I'll go to the second page. I'll have to adjust the screen, but then you don't have to load up on your Chromebook. You've got it. You're not going to lose your phone. You know what I mean?
Hey, but I might get distracted. Because if I go on Snapchat,
What's that?
go on Snapchat.
Yeah, go right ahead. Go right ahead. I know a lot of people do that, and it's fine. If it's on my computer too, if it's easier to get it off there, if you want to do it off of here, it's cool.
Is B part of EF? Because they intersect right there?
Yeah. Yeah. So there's a bunch of different ways. If you look at it, what are the ways to line
Because my
to
camera's
call it
again.
EF? Well, it could be
Okay, you wait, you can go. Actually, you're smart. Let me go on
It
camera.
could be line N.
Oh, yeah.
A bunch of them. And that's the thing. It's like, what do you see? What do you want to rely on?
Dang, I was just get closer. Because I can't see. Okay. I'll just wait.
Okay, I thought you were done.
I'm waiting for the second page after this.
There's another page.
What? You want to get all the way so the other people get in there too, or
Yeah,
you're
I was
she
gonna
she
wait.
blocked me out. You know, it's just funny. I'm just harassing people. It's part of my job description.
It's 8.
Not all of that.
Not all of it.
Right?
I already took the first page.
Yeah, there is. What's on here? See how you got E, B, and F are all in there? Or BE, or FE, or it's line N.
Oh, I have so much homework.
So you just have to pick which one you want. Yeah, this is really quick. Let me get the other side here.
Yeah, I'll just take the
There you go. This one you'll have to zoom when you get to it. Yeah, the textbook is something to be desired.
I'm not gonna do my homework because I'm not gonna do my list.
Dang.
They're slow. They're not the quickest things. Grab the fish with you.
Sorry.
Yes, we're doing all those pages tonight. Merry Christmas. I'm going to overload you with homework because that's what I do. Because it's more fun just to give you as much homework as possible. Yes, ma'am.
I'm supposed to tell you that Nicole Cortez wants to eat.
Oh. She's. Oh, but I'm not teaching Algebra 2 then. I just have the honors classes here.